Next is the pressure cylinder, alright, using a composite. Most probably, as you see, pressure cylinder are very heavy. So using a composite is pretty lightweight and is a better ergonomics, reduce stress on back and shoulder. I think then it should be ergonomics. Yeah, it should be ergonomics. And in fact, ergonomics, there is a name. Is the science and technology of producing and using plants for food and land reclamation. So I don't think it's this one. So I think it should be ergonomics. Okay, yeah, because it reduces your stress on back and shoulder because it's a lightweight. So same thing, 7 considerations again, if you I just need to constantly remind. So these are the 7 things that we often consider in our stuff. But take note that in previous video, for the pultruded bridge, there's only few stuff, only 4 things. Okay, but nonetheless, up to here, there's a filament winding. Filament winding is for those circular thing, because you run your fibers and your resins all going around this thing, so you create a form of circular thing. So you create your composite in a circular manner, then you just cut, and then you cut already, you will have a cylindrical cylinder, and then you can just use it to do whatever thing you want. So I think you get what I mean. So therefore, the manufacturing method is filament winding. Okay, so the load is the load. So the load, I think you know internal pressure because inside got air or whatever, right? But compound wall section, the definitions, alright, is a wall which is constructed of more than one material, alright. So yeah, it's a lot of terms you should take note of, and it's in terms of aluminium plus composite, and various winding angle of the robins to balance hook axle stresses. So this sentence, alright, actually talk about the filament winding method, okay, and therefore the winding angle is very important. I forget what is the angle, I think 45 or 50, I forget already, but you should go and take note of the filament winding, the tutorial question, I think. You should go and check it out lah. And to balance hook and axle stresses, and same thing, the how to determine the stiffness, everything you use the same thing again, your Young modulus, rules of mixture equals to the VF, Poisson ratio of the fiber, and the volume fraction of the fiber plus Poisson ratio of the matrix, volume fraction of the matrix. I think you get what I mean already. So these are the things of to learn. It's because I keep on saying that, but in case you may don't know what the hell I'm talking, so this is the equation coming out. So factor of safety is 2. Alright, why? So it's a static short-term loads because you're just carrying on your back for your mission. So after your mission, you can just take it down. So this is why it's that particular thing. And so effect of temperature, 5th one, I think it's more on the environment. I think, yeah, effect of temperature and environment. Okay, and therefore for this case, is more on the differential expansion between the liner aluminium and the composite. So I don't know how the aluminium works, but later on I think we will talk about it. Interface adhesion is just between the aluminium and composites, they are stick together by some adhesion. So the adhesion increase of temperature may actually decrease the adhesion properties. And pressure rupture test, I'll leave you to search if you need it. Joining and cutting, 3 aluminium liners are jointed to a central manifold through pipe connection. Over here, right, how they join and cut is that they are jointed to a central manifold through pipe connect. So I believe it's this type of manifold. Alright, so you have all these pipes all along. Alright, and then you connect your stuff all over here. Okay, this is a four so-called tubes. You connect to a this whole thing is a manifold. The manifold, the definitions of a manifold, alright, is this. Okay, if I were to search, a pipe or chamber branching into several openings. Okay, which is exactly the picture. So I think it's just what they're trying to say lah. Okay, so I think after this, let's talk about the case study. There is something talking about that. Same thing for your cylinder, but it's at page 33 of your reading material. And let's take a look on what are the important stuff for this. So over here, maybe I should go through one by one. I think you can just pause the video and read yourself. Alright, you can read yourself, and then you can read these equations yourself. Yeah. Okay, let's talk about the thing in important things. Alright, in case. So what spindle comes to my mind? So I check it out. It's actually this type of thing. Alright, it's how you how you actually use for your clothings. Alright, so these are the spindle. The metal piece is a spindle. Alright, or in other, if I were to just draw it out, so maybe there's some curvature, something like that. So you round around this thing. So this is spindle, and yeah lor. So the carbon fiber are being spindle are supplied through spindles passing through the fiber tensioning system, whatever lah. This is all for the. This is just description for your filament winding. Okay. I just want to show you the spindle in case in the future you may want to know also. Then yeah lor, but take note of the shape. As you can see, it's pretty nice. As you can see, it's like wow. Anyway, I'll not go into details of the equations, but take note, if you think about it, if you were to go to mechanics 4N, alright, and search for cylindrical vessels, alright, you'll get to see this type of equation. This is a thin wall cylindrical vessel because it's PR over T, alright, where TE I think is the thickness of what, I also don't know. Equivalent wall thickness. So what is the equivalent wall thickness then? Draw until like that, I also don't know how. Anyway, I'll leave you to think about it if you want to know more. Alright, but I think it's the, maybe I should search equivalent in value, identical. I will believe the equivalent wall thickness should be the average wall thickness, and this is how they calculate it. Because in order to calculate your stresses, I think this is the stresses, your hoop stress and your axle stress. This is the hoop in H, axle is in A. You can go to mechanics 4N and search for mechanics 4N, the playlist, alright, in my channel, if you forget or whatever, and then you can search for it. Alright, and I think this is it for the cylindrical vessels also. Okay, and therefore I think, yeah.